Welcome back to the 5.1 notes. This is page 2. We just got finished talking about standard form. We're going to talk about another way we can look at the equation of a quadratic, and that is vertex form or graphing form. Now the homework, and you will see other textbooks that call this general form. I tend to not use that. It's not as useful as vertex form. As a reminder, as we talked about standard form up here, we had y equal ax squared plus bx plus c. Now we're talking about vertex form. Here's our vertex form. F of x equals a. Incidentally, that is the same a as above, and I'm going to note that here. But a times x minus h quantity squared plus k, where hk is the vertex. So a is the same a as in standard form, which is going to be useful. This is super helpful because it gives us the h and the k. Notice, though, that it's x minus h and then it's plus k. You got to be paying attention to the numbers that we have in those places. It's kind of like the transformations where the horizontal translation works opposite the way we think it's going to, but the vertical goes the way we want. So I'm going to rewrite this up above here. I got an a times x minus h quantity squared plus k. Okay. The h is easy to pull out of this, right? Follows a minus, so here h equals 1. At the end, though, I got a k that's supposed to be plus k. This says minus 3. So we could rewrite this x minus 1 quantity squared plus negative 3, which gives me that k of negative 3. My vertex is going to be the point 1, negative 3. Now, 1, negative 3. My a is 1. There is nothing in front of my x minus 1. A equals 1. I know this opens up. It's also going to be the standard parabola. Remember, if a is bigger than 1, then this is going to be narrower or skinnier. If a is less than 1, it's going to be fatter. A is 1, which means like just the generic parent function, it's going to go 1 to the right and 1 up. It's going to go 1 to the left and 1 up. Okay. I could confirm my y-intercept by plugging 0 in. My y is going to be 0 minus 1 squared, and we got to be careful here because it is not just whatever looks like the constant. I get minus 1 quantity squared minus 3, 1 minus 3, which is negative 2, which tracks. That is what that looks like. So we went over 1, up 1. I'm going to go over 2, up 4. That's what my standard parabola does, and I'm going to do this on both sides. So here's the sketch of my graph. Notice here that it does not look like my x-intercepts are whole numbers, which means if I multiplied this out and looked at it in standard form, I probably would not be able to factor it. Okay? Could just be my funky graph, but whatever. Okay. Suppose we want to go the other way. Suppose we have a graph and we want to write the equation. So I'm going to start by looking at where my vertex is. I know my vertex is at -2, -3, which gives me my HK. Okay. So y equals, sorry, a times x minus h, quantity squared, plus k. I can plug in the hk part. I got x minus -2. I'm going to go ahead and write this out. Plus -3. So I have y equals a times x plus 2, quantity squared, minus 3. There are a couple of different ways I could find a. I have a y-intercept of 0, -1. Let's change colors here. I could plug in 0 and -1 for x and y and solve for a. So let's do that. What do we say? Y was -1. I don't know what a is. X is 0. I get -1 equals 2 squared is 4, a times 4, so 4a, minus 3. Now, be super careful. A lot of times people will leave the 4 after the a and they think of it as a times 4 minus 3. That's not it. That 4 is getting multiplied by the a. The 3 is separate. So I'm going to add 3 to both sides, divide by 4, and a is 1/2. So I'm coming down here. I got a final equation of 1/2. I got a positive 1/2, which matches the graph, which is opening up, times x plus 2 quantity squared minus 3.